Uh-huh. Uh-huh. Sure. And then did you go any further? Oh, you still okay, but Audrey, look at these two monomials. They look exactly like except they're coefficients. So they're like terms, aren't they? So guess what we're gonna do? We're going to? Yeah, you know what to do now? Okay, tell me what to do. Parentheses. Exactly right. Did you guys recognize that this is simply right? How many people wrote down negative 10 a to the 5th b to the 4th? Because that's the answer. Now, did anybody put down negative 10 a to the 10th b to the 8th? Yeah, this wouldn't be negative 12, by the way. It's negative 12 plus 2, right? So that's negative 10. Okay. So no one did this?
No one did what?
Because one of the mistakes that I see a lot is people write down, they blindly write negative 10 a to the 10th b to the 8th. They add the exponents when you're combining the like terms. Do we do that?
No.
Of course not. Because remember from yesterday, that's why, do you see why that distributive property step is important? As you can see, a to the 5th, b to the 4th stays the same, doesn't it? Look. Think about this. If I have negative 12 x to the second plus 2x to the second, does it become negative 10 x to the 4th?
No.
Of course not. That stays the same, doesn't it? So please remember that because I am using the distributive property backward, this is called the common factor. A to the 5th, b to the 4th stays the same, the common factor. Does that make sense? Does that, any question? Raise your hand. Are we good? This? All right, then. If you got that, why don't we try example 6? It's actually simpler than this one, example 6. So go ahead, try example 6 on your own. Tell me what you get, okay? Okay, now that you have some time to work at it. Okay, what should I do? First of all, how many terms do I have? 2. So I'm going to simplify the first term and then the second term. Of course, gathering all the numbers together is 10x to the second plus 3 plus 12x to the first plus 4. And don't I just get 10x to the 5th plus 12x to the 5th?
Yeah.
Can I multiply one of these numbers with like 5 and 2? For example, can I multiply 4 times 10 there?
No.
Raymond? No, because you got to follow the order of operation, right? You got to multiply first rather than, you can't just skip this addition and multiply, take this 4 and then multiply it over here. That'd be wrong. Okay. So, at this point, what should I do? Aaron? Yeah, you use the distributive property backwards to rewrite this as? Does that make sense? Okay. That's what we get, right? And of course, the answer is, class? No one wrote 22x to the 10th or anything, right? You can't add 5 or 5, the exponent. That'd be wrong. Right? This is combining what we learned yesterday with what we learned today. Okay? Hold on. This example 7a, actually there are 7a and b. This one seems really, really simple. Now, what's the difference between all these other examples? Look at your base. How is the base different? Now you have, Allie?
Now we have real numbers.
Yes, you have a number as a base, okay, instead of a variable. And for something like this, people seem to mess up. Now, you could leave your answer as a exponential form. You don't have to multiply everything out, okay? Yeah, so go ahead. It seems really easy. I don't know why people mess up. I know why, but I mean, well, hopefully you won't mess up. Go ahead, everybody try. Go ahead. As I expected, a lot of you got it right, but some of you didn't think it through. You just saw 5 and 5 as your base and multiply 5 and 5. Could we do that? No. The answer is no. We have to just get 5 to the 12. It's not 25 to the 12. Wait, don't we just multiply the base? Isn't 5 times 5 25? Why do we get 5 to the 12? Who could answer this question? Raise your hand. Why isn't it 25 to the 12? Because I see the 5 and 5 as my base. Don't I multiply them together? Why is it 5 to the 12, not 25 to the 12? Austin.
Well, because it's
parentheses, 5 times 5 times 5 times 5 times 5 parentheses,
Oh.
times 5
Okay.
times 5 times 5 times 5.
So what Austin is saying is you can actually write it out, right? Because if you wrote 25 to the 12, that means you're multiplying 25 12 times. That's not what's happening here. You have 4 5s and 8 5s, and you end up multiplying 12 5s, right? Okay? And also another way of thinking about this is, like I said, as soon as I change the base with the number, people seem to multiply them. Because when you have a to the m to the m times a to the n, do you multiply the base?
No.
No. You add the exponents because when you add the exponents, that's how many times you're going to multiply that base. Does that make sense? If you write 25 to the 12, you're multiplying this 5 a lot more times than you should have. Does that make sense? Okay? Does that make sense? Guys, do you see the kind of, do you see why I put star right here on this one? Okay, so please, okay, then try this problem. Go ahead, everybody.
The last one.
Yeah. Okay, did anybody put down 6 to the 4th?
No.
No. Okay, who has the answer? Raise your hand. Who haven't I called today? How about, I haven't called, Ethan, what'd you get? 36. How many people got 36 as your answer? You are correct. It is 36. Could I use that rule for adding the exponents for this?
Nope.
Why not?
Because
There we have the different bases. So it's basically simply just 2 to the second, which is 4. What's 3 to the second? 9. What's 4 times 9? Or you could think of it as this. This is really 2 times 3 to the second power if you think about it that way. That works too, but I like you to simplify. I think this is better. You don't. And so don't write 5 to the 4th or 6 to the 4th. That'd be wrong. Okay. That's wrong. Any questions?
No.
Yes, sir. Yeah, which is 36. So if you get 6 to the second, something that you can multiply it out, you should simplify and write 36. If you get 5 to the 12, you don't have to multiply that whole thing out. That's really big, right? But if it's something simple, you should multiply it out. Yeah?
So if it was like 4 cubed times 5 cubed, would that be like?
That's good. You can leave it. You can leave it. That's fine. Now here's your homework for tonight, by the way.